All right. We're here to talk about automation with config deployment in my little section of NANOG 81. And with that, I'll jump into a quick introduction of myself. I'm Ken Salenza, a Managing Director at Network to Code. I was your classic traditional network engineer by day, coder by night. I was always the one in the corner, having no one to kind of code with. But I've been kind of following that throughout my career. I converted to a full-time network automator back in 2016, and I've been in the industry since 2000 when I joined the Air Force in IT. And from there, went to a consulting company, then McKinsey, and finally here on Network to Code. So one of the things I'll kind of hear uh, throughout the community as people get into automation is something roughly around automation is kind of the art of deploying configuration, right? And I really think this is the common approach most people take as they're getting into network automation, right? And what I like to say about that is that's kind of like saying, let's automate the fun part, right? Because, let's face it, the configuration is the fun parts when we building devices, deploying new infrastructure, and really get into the nitty gritty of it. And they start looking at what they do. The average network engineer starts looking at what they do, and they say, "Well, I configure, IPsec tunnels, firewall rules, switch port configurations, and that must be where my time is spent." And there's certainly some truth to that, right? So what they start doing is building this one-to-one mapping of like some automation script, something like configure IPsec tunnels or deploy firewall rule, some playbook like that. And what they're looking, one of the things that ends up happening, you have this one-to-one mapping, a few variables that are set each time as part of their kind of their automation process, right? To actually deploy configuration. But again, I feel like this is the fun part of it, of actually networking. So not that's going to be your business driver, but that it is. It's kind of cool and fun to be a network engineer and actually go and deploying these configurations. Then they sit there and say, why isn't anyone using my automation? And there's a whole plethora of reasons, but I'm going to kind of concentrate on the ones here, right? So things you'll start hearing is, well, my change window was an hour and you only saved me a few minutes. So I'll just go the old school way. I'll just kind of hand jam it via the CLI. My change window is so short, I need to make sure everything works in time. Similarly, they're going to say, if I'm going to make the changes, I want to be the one to know what's going to go into those configurations. I'm in control. It's my butt on the line, to be honest, right? And then ultimately, if automation can't be run intended, I still need to verify everything myself. So great, you deploy this configuration, but I'm still stuck verifying the entire process actually worked and taking all the responsibility of that. Oh, so what are some of the issues with that kind of process, right? We'll talk about this kind of data curation and source of truth, right? And we'll talk a fair amount about source of truth throughout this presentation, right? And a lot of time is spent getting the quote unquote correct data for the configuration, right? And what do I mean by that? If you look at the bottom of the screen here, you see in red, you have a key value pair with the variables in red. These are the things that change from each deployment process to each deployment process, right? This data is kept transactionally, meaning the engineer has it, runs it, and that's it. It only exists for the length of that change window, and that's it, no longer. It's not kept in a source of truth, right? Which becomes a problem as you get further into your automation journey, because you have to keep doing this. You have to keep doing this analysis each time, right? And one of the reasons you have to keep doing this analysis is where is your data stored? It's stored in spreadsheets and Word documents and databases, right? But nobody actually trusts that data, right? What do they trust? They trust the actual configuration of the device. So they get the next tunnel, they say tunnel 135 is next available, but they still go and verify anyway, right? Spending all that time to begin with. The other problem is this verification problem, often pre and post changes. There's a tremendous amount of time spent on defining what the network is healthy, right? This takes a lot of institutional knowledge. And what I've noticed and kind of working with a lot of different customers is that no two network engineers within the same organization team do it the same. They may both run exactly the same commands and come to a different analysis on it. One sees a route that they think should be in there. The other is not concerned about that. They're only concerned about the change at hand, and they both can come to the same conclusion. By and large, people tend to run roughly the same changes, but slightly different, right? So they're actually all doing different analysis and looking at the same part of the data and the configuration slightly different, right? But they have to go through this point in the process. Then there's the network management aspect of it, bringing devices into and monitoring and inventory systems that kind of go along with the change management that happens throughout the various change windows and change workflows that happen within a given network environment, right? So as we break down these issues, right, this is what I see fairly consistently throughout various different organizations I'm working with. Really, there's a tremendous amount of time spent in curating data. The verification process takes, monitoring. Sometimes people don't concern themselves about it, but at the end of the day, I'm fairly consistent to see the actual configuration deployment process tends to be one of the simpler, or sorry, one of the shorter processes in this whole chain, right? So, how do we kind of actually identify where your time is going? How did I come up with this data, right? And one of the things I do often is a workflow analysis, kind of work with various different organizations through a workflow discovery or assessment process to understand what's going on with their automation strategy. So why is this so important, right? One of the things I find pretty universally is that most organizations don't actually know where their time is going, right? They're not aware of what other groups are doing, the various CAB review processes and approvals that are required for the entire system. The operations team isn't talking to the networking team to understand what data points they're getting. The architecture team defines a design, and the engineering team finds out that it doesn't actually work, so they go and develop the configurations in a way that actually works for them. So what should be tracked here, right? So these 4 data points I'm constantly working with my customers to understand is number of times a request happens, right? So weekly, monthly, yearly, 1, 10, dozen, 100 times that these requests happen. How much engineering time, right? Actually pecking away at the computer. How long does it take the customer, the requester, for this to happen? Meaning, if I put the request in on Monday, is it expected the next day, next week, next month? When am I actually going to get that back? And in there, what's the opportunity cost, right? So as an example, if you sell if you have a market fee that you're selling, and you could immediately charge your customer, and you have to wait until the actual networking team can get the change window in and deploy the configuration to actually start charging, there's real money lost there, right? So in this process, what should you be asking yourself? And basically what you want to ask yourself is, what would I tell a new network engineer that's going to work in my organization? And you're really going to concentrate on the tedious changes that need to take place, and you can't presume any institutional knowledge. So that engineer needs to be trained up on where to gather data, how to log into devices, how to identify which devices should be logged in for this change. And in that process, you can start understanding your workflow. But with all that said, when I kind of talk to the average networking team, I get something that looks like this, right? This is their first take. And the way they look at the world is request comes in, I configure, I close the request, right? And that's it. And they really start discounting their own work efforts, right? They only take their own tasks, not the entire workflow into consideration, right? They're not considering all tasks. So, put it another way, don't do this, right? What you want to do is something more like this, right? Really start understanding the different tools, systems, groups that are working in there, right? And this looks, starts looking a lot better. It really starts to show the complexity of what your networking groups are actually doing, right? But better yet, let's start overlaying how much time is required for these various different tasks. And what we start to see happening here is where most of the time is taking place. And I'm not going to go through all the various different steps here, but what I really want to concentrate on is the applied configuration step. Doesn't take that much here. 10 minutes could be very reasonable for a lot of these requests, just to paste in configurations in 1 to 2 or 3 devices, right? But the pre and post validation, data curation steps start taking a long time, right? So rather than take this automation deployment process of deploying configurations, let's see if we could start automating the other aspects and the other tasks that are associated with it. All right, so we'll start with the data curation step, right? One of the strategies I see is to limit the freeform fields from the requester and kind of work with your ITSM team. What I see the networking teams doing all across the board is taking data ownership of all requests that come in. What I often see is an Excel document comes in with freeform fields in there, and every field is non-normalized, not filled out. One FQDN in one cell, 5 subnets in the next cell, 2 IPs in an Excel, and there's no kind of rigid constraints on there, right? So really start working with your customer, your requesters, and with the ITSM tool or whatever the requesting system is to limit their options and to make sure the data that comes in is qualified. Right? Then to start moving your tunnel assignments and whatever get next type capabilities to a programmatically accessible attribute, right? A database, a netbox, Git, G-Sheet. It doesn't matter as long as you can programmatically read and make updates to this document store or data store, I should say. You're fine. The tool is a little bit less relevant. Some tools are, of course, better than others, but that's just the way it goes. And then start to develop automation to update the source of truth for those next tunnels and subnets. And then verify it, right? You want to actually go to devices. We're more than likely you're not going to be ready to just say, okay, it grabbed it from the source of truth. We're going to trust that it's going to deploy. You're still going to follow that process of verifying that those resources aren't there. Is tunnel 135 actually used? Yes or no? And then to develop the automation to create the configuration snippets, but not to deploy them, right? And there's a key delineation. And what do we mean there? Something like this, right? Where you take qualified data from a normalized data store, database, Git or something, some JSON schema for Git, with a qualified Jinja template, and the output you're going to get is going to be qualified, right? Good data in, good data out, garbage data in, garbage data out, right? And this is really a roundabout way of saying the source of truth is the cornerstone to network automation. I cannot stress this enough. It is truly the cornerstone to network automation, right? As you look at a system like this, you can't interject kind of bad configuration if you follow this process, right? There's no way to have an extra character, an extra configuration into your template without going through your CI system. Your database is going to do scheme enforcement, right? You can't get this completely non-normalized data, right? Okay, and if we go back now to our workflow, we start overlaying the tasks, the automation that are overtaking the previously manually tasks, we end up with something like this. And you can see that we are overtaking the tasks that take a serious amount of engineering time with a kind of simple process here, right? And we'll get into later how we kind of stitch together the system. But for now, we'll just kind of take it one at a time and just imagine an engineer just typing in Python, whatever that pi, right? Reserving a tunnel, getting the subnets, generating configuration, right? To be later manually copied over. The next step is the verification, which is kind of often the pre and post checks, right? Each engineer has their own tests. There's no standard definition of healthy. There's no baseline between data that's not SNP, right? I often, work with customers that have optic level issues because that's not captured by and large by SNP. So they don't even know if it's healthy before or after. Data is intended to change. If you're going to create a tunnel, it's going to be different. And that's going to have 100 tunnels before and 101 tunnels after. And this is going to, when you're doing your manual diffs between them, it's going to make it, kind of hard to kind of, see what's changed because you wanted to change and what changed because there's another issue that you didn't really realize. The raw text that's in there with all the timers and counters make it nearly impossible to effectively use diffs. If you have an OSPF or the BGP tables that you're kind of reviewing with the constant timer changes from the pre and post and trying to compare them and try to pattern match one change that might be actually incorrect between the sea of diff data, it's nearly impossible to do effectively. There still needs to be this evidence of change control, that there's a demonstration of pre-healthiness and post-healthiness of the device. So what I suggest is to really rethink how pre and post change validations are done, right? Get your data into structured data and then query that data, right? And what I mean by that could be anything from ensure all neighbors that are configured are actually up, right? And compare it to a healthy state, right? And then rerun all your checks each time. Well, if you're not running individual commands, you could just sit there and say, run these 5, 10, 20, 30 different, validations to say this device is healthy or these devices are healthy, because you're not actually manually going through it and just saying, define against healthy, not against this change. And it kind of changes the way to think about it, because you have this ability to kind of do more with less actual engineering effort on it, right? But you can see here, you have all this capability. Once you get into structured data, you could start querying this. You could sit there and say, I want to compare my routing table with the amount of routes, but not the timers. That's not interesting data to me. Timers are going to change constantly, so I'm not going to query that part of it. I'm not going to look at that data to understand anything. And it really removes that manual diff review, which just isn't that effective. We've all done it. We've all been there. And you do the best job you can, but you get to a point where there's just so much your eyes can, your eyes get so strained, you're gonna miss things, right? That's just the nature of the beast. Okay, so now again, we're gonna overlay this on top of our workflow and see where the automation task is, the additional automation task. But right, smack in the middle, there's this manually apply configurations, right? Which is fine. It's great. The engineer is still in control of their own destiny. They understand what's happening. They understand what's what they're actually pasting and what they're taking control of for their change window. Another kind of component of this is network management, and some organizations don't do this as religiously as others. One of the reasons is because of this exact process, right? People tend to put things into maintenance mode, forget to bring them out, bring it into inventory management system, forget to bring it back, bring it out of the inventory management system, forget to bring it back in, and so forth, right? And you end up with these dozens of unanswered alarms that people are now reacting because you don't have the correct processes in place for that, basically, right? During your change windows, you're not effectively managing all of that. Again, another part that's kind of primed for automation, right? To sit there and say, start maintenance, end maintenance. Take my devices out of maintenance so it's not being monitored. We're going to expect the links to go up or down during this change window, and that's great and perfectly acceptable. So at this point, you kind of look and you sit there and say, we still are deploying configurations manually, but we've automated most of the long engineering, tedious tasks of it, getting data, verifying stuff, reviewing hundreds of lines, thousands of lines of operational data that kind of bring no value, right? The whole point is to deploy the change to get the new service, right? And that's where the value is, and that's where you can kind of keep, I'm making the recommendation to, especially as you're getting started, to kind of keep that manually at first. Not in all conditions, but in a lot of conditions, I think it makes sense. Okay, so final thoughts here. So where are the benefits, right? The network engineer, I think this is this huge cultural benefit, right? We have this idea that all network engineers are dinosaurs. They just want to go in the CLI. I think there's a cultural consideration to really consider here. They need to be in control and to understand what's happening. And if it goes into this black box, black abyss, they don't know what's happening, right? They don't see what's going on. You allow the network engineer to retain that and to build trust into the automation system. When they see that every time automation is building the right configurations, all they have to do is kind of blindly apply them. All the operational tasks, all the data curation steps are being done. And then, a real huge benefit here is automation can't be blamed for the issues, right? You don't have right level access. You don't need right level access for this automation, right? It didn't do anything. The engineers need to ultimately take responsibility for the configurations they're going to push. Allows you to concentrate on tasks that actually take the most time when you do the actual workflow analysis, right? It can actually get your automation into production quicker. I would say both without deployment, as I'm stating, and even with deployment. Without deployment, it's obvious you shouldn't need to go as rigid of a control system for a read-only account. But even with, if there's such a trust into the automation, I believe they can actually get into your production systems quicker, even for configuration deployment, which of course you do want to get to. And it helps to build out that source of truth. Again, the source of truth is the cornerstone for automation. And again, just to kind of re-hit on that point, allows automation to be introduced with less pressure because there can't be issues kind of associated with it. Okay. And then we'll just kind of take a pause and just kind of relook at the same process that we had before, but relook at it within the automated world here, right? So we can take this process, 4 to 5 engineering hours down to less than 1, right? You can start stitching together everything. So the service request ticket comes in, makes an API call to your automation system, which gathers all the resources and verifies it. If all that works out well, sends an API call back to the ticketing system. No engineer was kind of had to get involved and sit there and say, here are the configurations, here's the qualified data, vars, and the plan for the configuration to be deployed. You still have to go through your normal change window, schedule change, CAD review process, all that fun stuff. Then the day of your change, you run your automation. You run your pre-automation, which does all your pre-checks, your network monitoring, remove systems from network monitoring, and then the engineer has the time to do to actually manually configure the configurations, which again they got from one of the previous automated steps. They know it's qualified, it's coming from a standardized JIT template, standardized data, and they know it's good to go. And they run their post-validation steps. And then finally, you can even have a kickback off to close a ticket with all of the evidence that's in there that says that this is a healthy device after the change, healthy device before the change. Here's the evidence, here's the text files or strings to prove that. And that is my presentation. Thanks. And I will be around to answer any questions you may have from this.
Hello, and thank you. I'm here with Ken live. Thank you, Ken, for presenting. We are monitoring the Q&A tab for any questions. I'll give it about 30 seconds to see if anybody has any questions.
Yeah, I'd like to thank you. It's just so well received and understood. There's no questions to be had. So hopefully that's the case.
All right. So, well, again, thank you for presenting.